Hey everyone. So if you've ever worked with data, you totally know this feeling. You get a new data set, you're excited to dig in and find some incredible insights, and you see it. Gaps, missing values. It can feel like a total roadblock, right? But today, we're going to flip that script. We're going to see it as an opportunity to become data craftsmen, ready to fix any gap we come across.
So yeah, your data has holes. First things first, this is not a sign that you did something wrong. It's actually one of the most common puzzles in data analysis, period. The real question isn't why there are holes, but what are we going to do about them? How do you fix the gaps without totally wrecking the story your data is trying to tell you?
When you get right down to it, you've got one fundamental choice to make. On one side, you can just delete the rows with missing data. It's simple, it's fast, and hey, you're left with a perfectly clean data set. But you're also throwing away information. On the other side, you can replace the missing data with some kind of estimate. This keeps your data set whole, but now you're adding a value that isn't, real. So how do you make sure your guess doesn't lead you down the wrong path? This is the big trade-off we're going to be exploring: simplicity versus accuracy.
To make this all feel a bit more concrete, let's use an analogy. I want you to think of your data set as this beautiful, intricate mosaic path. Every single data point is a unique, colorful stone. And a missing value? Well, that's just a missing stone. Our job is to be the craftsman who figures out the best way to repair that path.
So here's our game plan. We'll start with the puzzle itself. Then we'll walk through the options, kind of leveling up from the simplest fixes to the most expert techniques. We'll look at deleting, using simple fills, following the sequence of the data, and finally some expert-level estimation. By the end of this, you're going to have a full toolkit, ready to pick the perfect tool for any job.
All right, let's dive in. It's time to open up our toolkit and take a look at our very first option.
Okay, so our first technique is probably the most direct, straightforward one out there. Just get rid of it. If a row has a missing value, you just delete the entire row. We can call this the clean sweep approach.
Now, the trade-off here is pretty stark. On the plus side, it's unbelievably simple and efficient. Your remaining data is perfectly clean, but the downside is huge. You're literally throwing away information. This shrinks your data set and can even introduce bias, skewing your results. In our mosaic analogy, this is like finding a single missing stone and deciding to just rip out that entire section of the path. Sure, what's left is clean, but your beautiful path is now a whole lot shorter.
All right, so what if we don't want a shorter path? Let's talk about our first replacement technique. Think of this as the quick patch, a super straightforward way to just fill the hole. Here's how it works. You just calculate the average of the whole column, that could be the mean, median, or mode, and you use that number to plug the gap. It's fast, and it keeps your data set the same size. But, and this is a big but, there's a trap. This method is completely blind to context. It just assumes the missing value is probably close to the average. In our mosaic, this is like finding a missing pattern tile and just sticking a generic, plain gray rock in its place. Yeah, it fills the hole, but it completely ignores the unique color and pattern of the path around it.
Okay, now we're leveling up a bit. What if your data has an order to it? Like a time series tracking stock prices, or maybe daily temperatures. In that case, we can be a little smarter about this. We can actually follow the clues in the sequence.
This brings us to two really similar ideas. With a forward fill, you look at the last good data point you saw and you just carry that value forward to fill the gap. And backward fill, you guessed it, does the exact opposite. You look ahead to the next good data point and pull its value backward to fill the hole.
The great thing about this is that it's super intuitive, and it can actually preserve patterns, especially if the gaps are small. But it all hinges on one massive assumption, that the missing value is almost identical to its neighbor. Going back to our mosaic path, this is like looking at the stone right before the gap and just making an exact copy. It's a way better match than our generic gray rock for sure, but it really only works if the pattern is simple and the gap is very, very small.
So far, our methods have been pretty simple, maybe even a little crude. Now, it's time to explore the master craftsman's technique. This is a much more sophisticated and accurate method called interpolation.
So, unlike all our other methods, interpolation doesn't just look at one neighbor or the overall average. It's smarter. It looks at the data points on both sides of the gap to really understand the trend. Then, it makes a much more informed guess based on that trend.
The most common type you'll see is linear interpolation. It's pretty simple, really. It finds the known points on either side of the gap, draws a perfectly straight line between them, and then places the new value right on that line. The key assumption here? That the trend between those 2 points is steady and linear.
But what happens when the trend isn't a straight line? I mean, when is it ever, right? That's where something like quadratic interpolation comes into play. Instead of 2 points, it looks at 3 known points and fits a curve, a parabola, right through them. This lets it estimate a missing value along a much more complex, curving path.
Let's just put these two side by side for a second, because this is the real aha moment. On the left, you've got that simple straight line guess. But on the right, you have an estimate that actually follows the natural curve of the data. When your data has some momentum, or it's following a nonlinear pattern, this method is going to be way, way more accurate.
So, what's the bottom line here? Well, interpolation is generally more accurate, and it does a much better job of preserving the relationships within your data. The downside, it's definitely more complex to implement. This is the true master craftsman's approach, carefully looking at the pattern on both sides of the gap, and then crafting a brand new stone from scratch that perfectly matches the color, the gradient, and the flow of the mosaic.
Wow, we have covered a lot of ground, huh? From the simplest little patch to the master craftsman's finest tool. So how do you actually choose? It's not about which method is the best, but which one is right for your specific job. So let's wrap this up by summarizing the toolkit you now have at your disposal. And here it is, your final cheat sheet. If you need speed and simplicity above everything else, deleting rows might be the ticket, but you have to be okay with losing some data. If you just need a quick and dirty patch, a mean or median fill works, but remember, it ignores relationships. For data that's in a sequence, a forward or back fill is great for those small gaps. And finally, when accuracy is absolutely everything and you need to respect the data's trends, interpolation is your high-powered tool, even if it is a bit more work.
At the end of the day, every dataset really is like a beautiful, intricate story. A missing value isn't a mistake, it's just a missing page, a chance for you to practice your craft. So the question I'll leave you with is this. Now that you have the tools, how are you going to choose to fill in those missing pages to best honor the original story?